Hey guys, my name is Trevor Sullivan and welcome back to my video channel. I'm an independent content creator, so if you like this video and get something out of it, as well as subscribe to this channel, that will really help me to produce more training content that is useful for you. In this video, we're going to be exploring an exciting open source topic known as LXD, or I typically pronounce it just LXD. LXD is a really powerful tool that simplifies the process of creating Linux containers as well as virtual machines on a Linux server environment. So we're going to be exploring what LXD is and how you can actually use LXD yourself to create these virtualized environments. So for starters, let's understand why we would want to use LXD. So for starters, it's really easy to use LXD to automate virtual machine management tasks. LXD does work with containers as well, but for this particular video, we're going to be focusing on the virtual machine capabilities that allow you to deploy Linux operating systems on top of a host operating system. So using the command line tool that we use to interact with LXD, which is actually called LXC, we can use those inside of bash scripts or PowerShell scripts or other programming languages like Python or Go applications to automate various actions against our virtual machine environment. Also, LXD does scale up to cluster size environments, but you can also start small with LXD on just a standalone host. So if you just have an extra server laying around, you install a Linux operating system on that bare metal, you can use LXD on top of that Linux environment to create additional virtual machines. Also, LXD uses QEMU under the hood. QEMU is an open source utility that allows you to create virtual machines. However, if you've ever worked with QEMU before, it is a little bit challenging to use, and LXD actually kind of wraps that QEMU utility in order to make it easier to deploy and manage your virtual machines. LXD is also a client-server application. If you're already familiar with using Docker in order to deploy containers onto a Linux server, you're probably familiar with the Docker CLI tool that you use to communicate with the Docker engine or the Docker daemon, which is known as Dockerd. And it has this client-server architecture where the client utility basically talks to a Unix socket or a REST API that allows you to perform container management tasks. LXD works very similarly, where LXD itself is the actual engine that's running on your Linux server, and then LXC is the utility that we use to interact with that engine and create and manage our virtual machines on that Linux server. So if you're familiar with Docker and other types of client-server architectures like that, then LXD will feel very much at home. And using LXD is great for self-hosting network services. So if you want to self-host object storage services or Git servers like GitLab or OneDev or anything like that, and you want to create a virtual machine that's dedicated to a certain application. For example, I actually host a Rocket Chat instance on a virtual machine on top of my bare metal server. And so LXD is a great way for me to be able to create that virtual machine environment and install software into that isolated virtual machine so that I can manage applications independently from each other. All right, so next let's talk about how LXD actually works. As I mentioned, it does have a client-server architecture. So you're going to start with a bare metal server. I've got a custom build desktop that I use, for example, and I've installed Ubuntu Linux as my base operating system. You can install LXD on other operating systems as well, but it's really easy to install on Ubuntu Linux, and we'll take a look at how to do that in just a moment. Then you can install LXD, the engine itself, along with the LXC command line utility onto your host operating system. And then once the LXD engine has been installed, you can then use the LXC CLI to create virtual machines that use different operating system images. For example, maybe we want to deploy a virtual machine with Alpine Linux, maybe we want to install another one with OpenSUSE Linux, and then maybe we want to create additional virtual machines that run different versions of Ubuntu, like Lunar Lobster 2304, or maybe Jammy Jellyfish finish 22.04, or maybe we want to test software on older, outdated versions of Ubuntu just to increase the reliability of our testing. And so we could use LXD to deploy older versions of the same operating system. So you really have a lot of flexibility that's given to you by deploying LXD to your physical host. Now you might be asking yourself, well, where exactly do these different operating system images come from? Do I have to manually download ISO images for each of these operating systems and then mount those to a virtual machine? Well, the answer is no, you don't have to, because you can actually use what's known as an image server with LXD, and there's actually a default image server that's provided. So you don't even have to worry about setting one of these up yourself if you want to use the default images that are available over at images.linuxcontainers.org. So that server actually hosts the operating system images that are fully up to date for some of the most common Linux distributions like Alpine, OpenSUSE, Ubuntu, Kali Linux, and a whole bunch of others. And then you can simply use LXD to deploy virtual machines using those pre-built cloud images. Now, you can also create nested virtual machines as well. So by default, LXD, when you create a virtual machine, will actually pass the CPU hardware extensions from your host operating system into the virtualized environments. And that means that you can actually install LXD on top of your virtual machines and then create LXD virtual machines inside of that virtualized environment. Now, there's kind of limited scenarios as far as where or why you'd want to do this, but just keep in mind that this is supported by LXD, and it just gives you more flexibility with how you deploy applications and operating systems into your environment. All right, so next is going to be how do we install LXD itself. So we start with that bare Ubuntu operating system, right? We install that on our bare metal server. And then we want to install the LXD package. Now, LXD is actually provided by a Snap package from the Snapcraft store, which is hosted by Canonical, the creators of Ubuntu Linux, over at snapcraft.io. So the Snap Package Manager allows you to very easily install LXD with the LXC CLI utility to manage it, simply using a snap command. So we just say snap install. The name of the package is just LXD, very easy to remember. And then after you've installed the package with Snap, we also need to initialize the LXD engine to do a bunch of setup stuff. We're not going to get into all the nitty-gritty details of that right now, but there's an init command that you need to run, just called LXD init. And that's going to run through the initial configuration wizard that sets up your networking, your storage pool, and a bunch of details about the LXD service or the engine or the daemon that's running on your host operating system. And then after you've got LXD initialized, you can then start to create virtual machines from the images that we just talked about that are hosted on images.linuxcontainers.org. All right, so now that we've initialized the LXC engine, we're ready to create a virtual machine with LXC on the LXD engine. So the basic command structure that you're going to want to be familiar with is LXC launch. So you have the launch subcommand under LXC. And again, LXC is communicating with the LXD engine. And then we want to specify --VM because by default, when we use the launch command, it's going to create a containerized environment rather than a virtual machine environment with a dedicated kernel. So we need to do --VM to indicate to LXD that we do want a separate virtual machine with its own kernel and host operating system, right? Then we can specify an image from our image server that we want to use. We'll just use the default one for now. And then we're going to specify a unique name for the virtual machine that we want to create. So the structure of this command is pretty easy to remember. There are some more advanced configuration options, but for now, we're just going to keep things really simple. So let's say we want to deploy a virtual machine running Ubuntu server. Well, all we need to do is say LXC launch --VM, because again, we're creating a virtual machine. Then we specify images, and images right here actually references a default remote server containing the images, and that's the images.linuxcontainers.org. You don't have to specify images here if you're just using the default image server, but it's a good practice to know exactly which image server you're pulling an operating system image from. After the colon, we specify the operating system distribution that we want, so either Alpine or Ubuntu or Kali or Mint Linux. All of those are different supported distributions of Linux. And then after the / here, we specify the OS version that we want to deploy, followed by a name for the virtual machine itself, like Ubuntu-Lobster. So that's all we have to do to create a virtual machine, and then we can start to run various commands on that VM. Now, let's say we wanted to deploy a virtual machine running Alpine Linux. Well, not all operating systems are the same, and if we try to use LXC to create an Alpine Linux server here as a guest virtual machine, we're actually going to run into an error. So all we're going to do is change the distribution and version of the operating system that we're deploying and also give it a unique name. But if we try to run this command, we're actually going to get this error down here that says this image used by this instance or VM is incompatible with secure boot. Please set this option security.secureboot equal to false, and then you'll be able to boot the virtual machine. So in order to work around that, what we need to do is make sure we add on this extra option called --config security.secureboot equals false, and that will allow us to boot an Alpine Linux guest virtual machine on LXD. All right, so now it's time for us to actually learn by doing. I always encourage people to get some hands-on time with LXD, so we're going to go ahead and do that now. So the LXD homepage is available over here at linuxcontainers.org. And then if we check out images.linuxcontainers.org right here, this contains the default images that are available for LXD virtual machines and LXC containers. So keep in mind that there are container images, but there's also VM images here. So make sure that you're looking at this VM column when you're trying to locate an image that you want to use to create a LXD virtual machine. All right, so what I'm going to do is fire up a new terminal, and I've already got my bare metal virtual machine up and running. The name of it is just Wyoming here. So I'm going to SSH into my server here, and I'm going to make sure that I have LXD installed. So I'll do snap install LXD. And of course, I need to do that with sudo here, so I have root permissions. And as you can see, LXD is already installed. Also, I've already executed the LXD init command here and ran through the wizard, but I used all of the default options. I didn't customize anything as far as the initialization process goes. So once we've done that, we are ready to create a virtual machine. Let's go ahead and copy the example that I had over in the presentation right here. So I'll just paste this in, and we're going to create a new Ubuntu Lobster virtual machine. Remember, I said that images right here refers to the default image server at images.linuxcontainers.org, and then we are going to search for a specific Linux distribution and then a release version as well. So if you wanted to deploy a different release like Alpine Linux, or maybe something like BusyBox or CentOS or Debian or OpenSUSE or Fedora, there's a whole bunch of different Linux distributions available, as well as different versions of each of those operating systems. Just make sure that in the far right column it says yes here. All right, so if we run this command to create our virtual machine here, we should see that the image is downloaded from the Linux image server, the linuxcontainers.org image server, and this will take just a moment to run, so it's got to make sure it downloads that specific version of the OS image, and then it will go ahead and launch the virtual machine. Also, we could create virtual machines from other operating systems. All we need to do is just replace this distribution and the version right here. So once it downloads that operating system image version, it'll extract it or unpack it on the local file system. And then once the OS image has been unpacked, LXD can go ahead and create a new virtual machine from that image. And then what we can do is list the running of virtual machines. So we'll just do a LXC list command to list all the different virtual machines. And we should see that our new VM named Ubuntu Lobster is up and running here in just a moment. So we'll let this unpack. And of course, it is better to have solid state storage SSDs are pretty common these days, but even better is to have an NVMe-based SSD, and that'll really give you top-notch performance for your virtual machine host. I don't think I have NVMe in this particular host, so it's probably a little bit slower than if I did have an NVMe drive, but just keep in mind that that'll help improve your performance. All right, so now you can see that our virtual machine, Ubuntu Lobster, is starting. So we'll do LXC list right here, and we should see a bunch of different VMs running. As you can see right down here, we've got Ubuntu Lobster up and running. So now, how do we actually access this virtual machine? Because we didn't provide any kind of authentication details, right? Well, LXC actually has the ability for us to interactively execute commands on our virtual machines. So to do this, if we just do LXC help, and we should see this exec command right here, this allows us to execute commands inside a virtual machine instances. So let's do a LXC exec -- help. This will show us the basic command structure here. Now we need to specify our virtual machine instance name and then a -- and the command line that we want to execute. The command line that you run doesn't necessarily have to be something interactive. You can just kick off a background job if you want to, but you can get an interactive shell on that virtual machine as well if you want to manage it. So let's do LXC exec, then we'll specify Ubuntu Lobster as our VM name. We'll put the double dashes here and specify maybe IP adder, and as you can see, that runs a command and returns control back to our host shell. But if we say bash, which is pre-installed on Ubuntu Linux images, you can see that we now have an interactive shell inside of that virtual machine. One of the most common things you'll do after deploying a new virtual machine is just to do an apt update and apt upgrade -- yes, and that will make sure that all of your base operating system image packages are up to date. As you can see, this image is fully up to date here, so it didn't have to update anything. But then at this point, we have the ability to install any software that we want to. So we could say apt install docker.io -- yes to install the Docker engine. If we wanted to create containers on this virtual machine that we created with LXD, it's really up to you what you want to do at this particular point in time. Now, if you want to enable this virtual machine for SSH access, you can do that, but be aware that the default network configuration of LXD is to actually use a bridged networking setup, which means that this virtual machine is actually running on an isolated network, a virtual network, on the actual virtual machine host. So it's not directly connected to my network. And in a separate video, we'll take a look at how to set up LXD to actually connect virtual machines directly to your host network. So in any case, at this point, you are ready to go ahead and install whatever applications you want to on this host. You can run background services if you want to that reach out to the internet and gather data, or reach out to other devices on your network and talk to different APIs and things like that. But that's how we can use LXD to spin up a basic virtual machine. Now let's go ahead and practice spinning up an Alpine Linux virtual machine really quick as well. So I'm going to do LXC list here, and I should still see that my Ubuntu Lobster VM is running here, and we can see that it has an IP address on that isolated virtual network on the host itself, so it's not directly connected to my physical network, and it also has a second network interface because we installed the Docker engine. So let's do an LXC launch -- VM, and then we'll say images server Alpine 3.18. Again, you can grab that version information over at images.linuxcontainers.org. So if we go through and look for Alpine, we can see there's 3.15, 3.16, 3.17, and finally at 3.18. And this is an AMD/Intel 64-bit server. And you can see right over here that it says, yes, there is a virtual machine image available for it. So we'll go ahead and specify a name like Alpine 01. And you're going to see that it downloads the image for the OS, and it does actually create the virtual machine. However, we saw that error message during the presentation. That means that when we actually try to boot the virtual machine or start the virtual machine, it's actually going to fail. And that's where we need to actually set the configuration to disable the secure boot option. Now, Alpine Linux is really nice because it's a much smaller image, so it's faster to download, it's faster to unpack, and it's faster to create new virtual machines. And so in just a moment here, we should see that error message pop up. And sure enough, there is the error message. It says the image used is incompatible with secure boot. So what we need to do is just change the configuration. And if we try to do that on the launch command here, we'll say --config security.secureboot equals false. We're going to get another error message that says the VM already exists. And again, that happened because when we first ran the launch command, it created the VM, but it failed to boot. So one option would be to delete the virtual machine with LXC delete, or we could actually update the configuration of the virtual machine using the LXC config command. For now, I'll just go with the easy option, which is to delete the VM. And then we'll try to recreate it with the secure boot setting set to false, and that should work just fine here. All right, so there you can see we are starting our Alpine 01 virtual machine. So now let's do an LXC exec command on Alpine 01 -- and then bash is not actually pre-installed in the Alpine Linux environment. So if we try to exec bash here, you can see that that is going to fail, but we should be able to use the sh shell and gain a shell on that virtual machine. So the package manager for Alpine Linux is apk. So if we wanted to do any installs like apk install vim, for example, let's do apk add vim actually. We'll go ahead and just download that software package, get it installed. We could do the same thing for Docker Engine. We could do the same thing for any other software packages that we want to. Maybe you want to use Podman to run containers on your Alpine Linux VM. It's really up to you what you want to do, but that's how we can create VMs using both the Ubuntu and the Alpine images for LXD. In any case, I hope you found this video helpful. Again, please like if you found this video helpful, subscribe to my channel, and please share a link with your family, friends, and professional contacts, and help me grow this channel into something much bigger than what it is today. Thanks for watching, and we'll see you in the next video.